Hey guys, Bruce KC1FSZ here, giving a update demonstration of the W1TKZ digital repeater controller project. We're doing some bench testing today. Here we have the radio interface board. Here we have the digital control module. And this board is simulating the connection to two radios through the DB25 connection. This button simulates the carrier detect on the VHF side. This button, the carrier detect on the UHF side. And this green LED is tied to the push-to-talk control for the VHF transmitter. I've also connected temporarily an audio amplifier and a speaker to the audio input of the VHF transmitter so that we can listen to the tones that are being generated by the repeater controller. I'm going to show a few scenarios here. The first is a quick kerchunk coming in on the VHF receiver. What we'll see is the transmitter key up. After the receive drops, we'll see the hang time, the courtesy tone generation, and after a few seconds we should hear the repeater ID itself, because this is the first activity in a few minutes. So we'll simulate VHF activity. We see the green LED turn on, showing the transmitter is keyed. After the hang time interval, the courtesy tone is generated, and after a few seconds we should hear the ID. And then the transmitter drops. Just to show, if I generate another kerchunk, again we see the transmitter key up, hang time, courtesy tone. This time we'll hear no CW ID because the repeater has already ID'd itself within the last 10 minutes. So further testing of the hang time feature. This time we're going to simulate two stations calling back and forth to each other inside of the hang time interval. This will be a crossband simulation, so we'll have one station on the VHF side and one station on the UHF side, just to show that as long as the stations are going back and forth, the repeater stays keyed. There's no courtesy tone generated until the final call. So here we'll simulate the VHF activity being received, followed by the UHF station calling back. The VHF station calls back again. Finally, the UHF station one more time. Transmitter stays keyed throughout. The last call, transmitter drops, courtesy tone is generated. Okay, next we're going to show what a timeout looks like. And just to make things go a little quicker here, I've configured the timeout interval for 20 seconds and the lockout interval for 20 seconds as well. So I'm going to simulate now a long talking station coming in on the VHF side. We see the transmitter is keyed up as usual, and I'm just going to hold the button down, simulating receive activity on VHF. We'll wait for the timeout interval to pass. Okay, notice the transmitter has dropped. The repeater is now timed out. Receive activity on UHF, VHF is being ignored. Transmitter stays unkeyed throughout here. Now after the last receive activity is detected, we now start counting down through the lockout interval. The way a lockout interval is indicated, the end of the lockout interval is indicated with an ID. So we'll wait a few more seconds to listen to the ID. Transmitter keys and sends out the ID, indicating that the lockout interval is complete. The repeater is now working normally. Last thing I just wanted to show, important thing, the shaping of the symbols for the CWID and the courtesy tone. I've just triggered on the oscilloscope here just to show that The transitions are smooth through the zero crossing. This is just a picture of the gap between two CW symbols, just to show that there's no discontinuities. That's all we got. 73s. Have a good one.